Welcome to lesson for Thursday, 10:15. Talking about solving systems with quadratics. We talked a lot about solving systems. We're going to do it this time with quadratics, which means there are x squareds, maybe even y squareds in the equations. We're going to be using both substitution and elimination methods. The first example, I have two equations. One of them is an x squared, which means that's a parabola, and the other one is a line. Now they're written in standard form or in some other type of form, not y equals. But what I have is a line passing through a parabola, and it's going to pass through at 2 points. So this system's solutions will be identifying what those 2 points are. Now we're going to solve this using elimination, which means I need to cancel out one of the variables. But since x squared and x are the ones that I want to work with to solve, we really want to always be canceling the y values on these. Now this one's easy because the y's already canceled. Let's say that this had a 3. Well, then I would have to multiply the second equation by 3 to get those to cancel. Or maybe multiply just by a negative to get them to cancel. As they are right now, they already cancel, so no multiplication is needed. X squared comes down, x plus x is 2x, negative 1 plus 4 is 3. So this is my equation that I need to solve. And I'm going to solve by factoring, which means I need to put it in standard form, subtract 3 over, get it equal to 0. Then I'm going to factor this, easy factor, factors of 3 that make 2, x plus 3, and x minus 1. Zero product property then says if I set each of these equal to 0 separately and solved, I would get negative 3 and 1, solving by factoring. That means I have found the two x values where these meet. So the 2 points where they meet is at negative 3 comma something and 1 comma something, because all I have right now are the x values. So I need to find the corresponding y's. I'm going to use the second equation in the problem, x plus y equals 4. And if x equals negative 3, and I plug negative 3 in for x. Solve to get y equals 7. So the first point is negative 3 comma 7. And do the same for x equals 1. Plug 1 in for x. Solve for y. I get 1 comma 3. Those are the 2 points where these two intersect in the solution to this system. That's elimination. Let's talk about substitution. Now to do substitution, I make something like this where I have x squared and y squared, which is actually a circle. This is a circle with a radius of the square root of 29. We'll learn about that later this year. And y equals x plus 3. So what I actually have is a circle and a line passing through it. And it's going to hit at 2 separate points. We need to find those 2 points. So the substitution says, if I know that y equals x plus 3, I can substitute x plus 3 in for y into the other equation. So I substitute x plus, I don't know why 4 is there, x plus 3 in for y into this other equation. And you can see that right here. X squared plus not y squared, but what y is equal to, which is x plus 3 squared, equals 29. That's substitution. Now I've got to clean this up. This is something that a lot of people get wrong, so I have made a big deal of it here, including talking about killing a puppy. This is one of the major algebra mistakes that if you do that, unfortunately, I'm afraid that somewhere in the world, a puppy dies. Don't kill the puppy. Please don't kill the puppy. Please don't mess this up. X plus 3 squared. X plus 3 squared is x squared plus 6x plus 9. It is not x squared plus 9. If you leave out the 6x in the middle, that's when a puppy unfortunately dies somewhere, somehow, some way. Okay, it's not up to me, it's up to the universe. Reason is, if you're talking about x plus 3 squared, and what I'll get, let me show this here off to the side, x plus 3 squared, and people think, oh, I'm squaring these. X squared plus 3 squared, or 9. Done. Wrong. Puppy died. Okay, we saved it. Puppy's still alive. x plus 3 squared means x plus 3 times itself. Squared means times itself. Now distribute this out. You would get x squared plus 3x plus another 3x plus 9. There is a 6x in the middle. Do not leave out this middle term or the entire rest of the problem is wrong and you're going to lose a lot of points. And a puppy dies somehow. Do not mess this up. How big of a deal can I make out of this? All my scribbles. Okay? Don't leave out the middle term. Okay, that's enough of a deal out of it. So that means that, let's start from scratch here. If I have substituted x plus 3 in, and I need to simplify this, it comes out as x squared plus 6x plus 9. Great, let's clean it up. X squared plus x squared means there are two x squareds, combined like terms. Let's get it in standard form, which means I need to set it equal to 0 by subtracting 29 from both sides. So I get 2x squared plus 6x minus 20. And you can factor this as is, but I do notice there's a GCF of 2. So I'm going to divide everything by 2. 1, 3, 10, 0. Reduce that equation by dividing everything by 2. Now it's an easier factoring problem. 10 would be 5 and 2. That makes 3. And then I solve zero product property. X equals negative 5. X equals positive 2. You could also solve this with completing the square if you prefer that to factoring. So you could complete the square with this by adding in 2.25, minusing 2.25 to balance the equation. X, if you're really good at completing the square and you just really don't feel great about factoring, you can solve by completing the square at any point. And then finish solving this by square roots. So I add the 12.25 over, take the square root, subtract 1.5. Negative 1.5 plus or minus the square root of 12.25 would also give you negative 5 and 2, the exact same answers. Okay? I don't care which way you go. So since I have those two x values, I need the corresponding y values. So I plug those back in and use this one. It's easier. Plug those in for x to get the corresponding y's. And here are the 2 points where the circle and the line intersect. All right, you can start your homework, pop back into the live session if you have questions.